Hello, this is Chinyere. I have a presentation on bats. Bats are not only the flying mammals, they are over 1,400 species of bats worldwide. Without bats, say goodbye to bananas and mangoes. Bats may be small, but they are fast little creatures. Question 1. The species found are for Island 1, we have 13, Island 2, 11 species, 3, 12, 4, 10 species, and 5, 9 species, having a total of 19 species found for question 1. And then in question 2, the individuals found in each species are Island 1, 115 individual, Island 2, 68 individual, Island 3, 97, Island 4, 32, and 549, having a total of 361 individual found in this species, which is called bat. Using the R Studio, I had to get the estimate of the richness, the diversity, and the evenness using the Shannon index. From there, you can get the richness, diversity, and evenness of each of the 5 islands, which is stated in the table. Then the most diverse of the islands are Island 4, having a diversity of 2.045135, and then it is not consistent with question 1 and 2, because in question 1 and 2, Island 1 tends to have a higher value, while in question 3 here, Island 4 tends to be the most diverse. Using the R Studio, I was able to estimate the different sizes of the island using the PAL model. The output indicates that an asymptom was not found here, which I analyzed using the R Studio. So then, to determine the best model, a multi-averaged spatial area relationship curve was constructed for the model that contributes the most. So details of different models appeared in the R Studio. So, but the most of the model that contributed the most is the Wellbone for having the 0582. 4 patterns of biodiversity. They have the species area relationship, intermediate disturbance hypothesis, latitudinal gradient of biodiversity, and diversity productivity relationship. Then the types of abundance are most species are rare, few are common. Common species are widespread, rare species are restricted in distribution. And lastly, species tend to be the most abundant at the center of their distribution. For my data, I'll be choosing 2 patterns of diversity. I'll choose the latitudinal gradient of biodiversity. I'll choose that because more species are tend to be seen at the tropics than the poles. I will explain further using the types of these gradients. We have the aliens rule. Here, the limbs and the ears of animals are shorter towards the pole. But then those animals with having the same species, their ears and limbs tend to be bigger in the tropics. Using Rabble's rule also, plants and animals are generally smaller at the poles but tend to be bigger at the tropics. For the second pattern of diversity, I would be choosing the intermediate disturbance hypothesis. Here, at low levels of disturbance, more competitive organisms push subordinate species to extinction and dominate the ecosystem. At high levels of disturbance, due to human impacts like deforestation, all the species are at risk of going extinct. Only the most resistant species survive. And lastly, at the intermediate levels of disturbance, diversity is thus maximized because a mixture of species coexists. The implications include low productivity, exotic or the invasive species. Here, the invasive species comes in and disrupts the community structure, but then when the exotic species doesn't cause much problem to the environment, but both of them they affect the community structures. Some invasive species are exotic, but exotic species are not invasive. Then you talk about the habitat degradation. For the habitat degradation, we have the pollination, the light pollination, noise pollination, and also the biological magnification, whereby we talk about the consumption of fat soluble. Then we also have the climate change, the habitat fragmentation, where you talk about the habitat loss, the isolation of remnant habitat patches. I would love to protect the islands below, Island 2, 3, 4, and 5, especially Island 4 and 5, because these islands tend to have small species in their community, and because of that, they are isolated and so that they don't go extinct. So I would like and love to protect the islands to enrich and so that there will be high productivity and abundance, because as area increases, richness increases, and more species will be needed, leading to more species diversity. So for number 8, question 8, talk about facilitating the spread of contagious catastrophe, promoting outbuilding depression, are costly to build and maintain, have high edge interior ratios, that is the lecherous edge effect, that the negative effect, which will then give rise to ecological trends. For question 9, Aristotle was used in comparing the samples. For the first part, find out that island 1, 2, and 3 had the highest values, richness value. Then island 4, 5 had the lowest abundance. Island 4 had 32 individual, that was the lowest amongst all. So we had to do rarification to determine the species richness from the resulting sample. And also it allows the calculation of species richness for a given number of individual sample based on the construction of the rarification curve. So after the verification, we have island 4, 2, and 3 becoming the highest instead of 1, 2, 3. If you compare this with the answers we got from question 1, they are not consistent. Studio was also used to solve question 10. If you check the graph and also the output layout, you find out that island 1, 2, and 3 tend to be more similar, having 92, 40, and 25, more similar than 4 and 5, that is island 4 and 5 having 19 and 8. So if you get this and check with question 1, find out that they are consistent with each other.